systems of inequalities. So systems, remember, are two equations like we had. This time we're going to have two equations for inequalities. And when we were graphing inequalities, we were shading sections of the graph either above or below the line. Again, we're going to be shading sections of the graphs, but we're going to have two lines. So we're looking for the shaded section that overlaps for them. So here's our first example. We're going to graph the following linear system of inequalities. Y is greater than or equal to 2x minus 4. Y is less than negative 3x plus 2. So we're going to use the slope and y-intercept to plot the 2 points for the first inequality. And since this first inequality, we're at negative 4, so that's our starting point. And then our slope is 2, so that means we go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, forever. And since it is a greater than sign, like we did yesterday, it's a solid filled in line. And so we're going to pick a point in the inequality and shade the appropriate region. Now, since we talked about greater than, I'm going to pick a point above. I'm obviously going to choose 0, 0. Anytime you have the opportunity to pick 0, 0, it makes your life so much easier because there's less math. So in the first inequality, because that's what we graphed, I'm going to plug in 0 for x and 0 for y. 2 times 0 is indeed 0. 0 minus 4 is negative 4. Is 0 greater than negative 4? Yep. So I'm going to shade the region above the graph. Greater than or equal to, we're shade above. Now we have to do the same for the second inequality. Well, the second inequality is y is less than negative 3x plus 2. So our starting point is going to be up here at 2. But this time I'm going to go down 3 over 1, down 3 over 1. And it's going to be a dotted line because it is the less than symbol, right? So when it's less than or equal to or greater than or equal to, we're solid line. When it's less than or greater than, it's going to be a dotted line. So now I'm looking for the section that these shades overlap. Well, over here, I'm already in this section here. Okay, I'm above the green line. So I'm either going to be shading this part or this part because it has to overlap. We're going to overlap in the same shaded region. So here I picked the point negative 2, 2. So negative 2, negative 2. I'm seeing if I need to shade this region where they overlap. And so I plug in negative 2. Negative 2 times negative 3 gets me positive 6. 6 plus 2 is 8. Negative 2 is less than 8. That is true. So I need to shade the region that is overlapped by these two lines. So I shade between the green line and the blue line. The solution to the system of inequalities is always the region where the solutions overlap. Okay, this is the region to the left of the green line and below or to the left of the blue line. That is the region that is it's overlapping. Now, I know some of you, when you get to doing your homework, are going to want to shade the first section. Do that, but do it lightly. And then when it comes to shading the section they overlap, you can darken it or you could take a highlighter to go over it so that it's a little bit darker. So let's try another one. We're going to graph the following linear inequalities. Remember, when you're graphing in linear inequality, you have to have it in slope-intercept form. If it's not in slope-intercept form, it's not going to work. So here we go. Y is greater than negative x plus 4. Y is greater than x minus 2. Both of these are greater than signs, so both of the lines should be dotted instead of solid. So we're going to use the slope and y-intercepts to graph or plot the points. So here we go. We started at positive 4. That was the y-intercept. I went up 4. And then it was negative 1. So I go down 1 over 1, down 1 over 1, down 1 over 1. And then to figure out which region I shade, I need to pick a point to double check. So I'm going to pick a point in this region. I'm actually going to pick 0, 0 and see if it works. So negative 0, okay, plus 4 does that make sense to say 0 is greater than 4? No, so I'm not going to shade where 0, 0 is. I'm going to shade in the other region. I could also pick a point here to double check. So let's go ahead and pick 1, 2, 3, 4, 1, 2, 3, 4. If I pick 4, 4, what makes sense? 4 is greater than negative 4 plus 4. Well, negative 4 plus 4 is 0, so 4 is greater, so this is true. So I've shaded correctly for this first equation. Now I need to plot the second equation. So this is at -2. So I go down to -2. That's my starting point. The slope is 1. I go up 1 over 1, up 1 over 1, up 1 over 1 forever. And I graph again another dotted line because it is greater than. So now I need to be looking for the section that overlaps. Well, I've already got this shaded region here. This is a shaded region from the first line. Here is also a shaded region. So I want to know if I'm shading above this dotted line or below it. It is greater than, so my first inclination should be to shade above, which did happen, but let's double check. I'm going to use the point 0, 0. I plug in 0 for y and 0 for x. 0 is greater than 0 minus 2. That's true, so I know I'm shading above the blue line. But wait, the solution has to be where they overlap. Well, I shaded this section and I shaded this section, so the bit that they overlap is this triangle right here. See how they're overlapping? So now the overlap is my solution. Again, you can shade on the graph. Just make sure that your final answer or the part that overlaps is shaded darker than the rest. Okay, you may work on your homework and you may work with a partner.